Hello everybody. Hey, wanted to go and make a quick little video explaining the C4 worksheet, molecules and compounds, so that if you did get ahead, you had somebody there to give you some advice and or possibly some direct instruction on this. So please note this is called C4, molecules and compounds, and all of this would be something you would accomplish after you've watched the videos that are attached to this Google Classroom assignment. Please note that molecules and compounds, they share some similarities by definition, but they are not exactly the same. And so I hope that you guys can go and do a little bit of your own research from either readings or some Google searches. But I do want you to go ahead and define terms like atom, molecule, and compound. Please remember that all compounds are molecules, but not all molecules are compounds. And see if you can't go and figure out the little details, the nuances there, the minutia that goes and separates those two definitions. Also next year, what is the smallest unit of an element? That goes back to your first definition, which happens to be an atom. And then what is the smallest unit of a compound? Well, that's the other definition of the three here. So hopefully you can figure out the answer to those two questions. Now, I'm assuming you've gone and watched the TED Talk about why elements bond, at which point you're going to have a way to answer this next question, which is asking you, what are the two ways that the atoms come together? Give an example for each. Please remember that one of them does involve sharing of electrons, and the other one involves taking or stealing of electrons. And I hope you can go and find your definitions as well as create some examples from that TED Talk. All right, now scrolling down below, we've got our first chart here. Now, in this chart here, I'm asking you to go ahead and fill it in, and I'm going to give you a little bit of help, excuse me, on the first one. And what I'm going to ask that you do here, there's a little bit of technology formatting that I want to make sure that you're comfortable with, but also just to go and get this chart filled in, please know that the internet is your friend, and that's totally acceptable. So first thing you're going to tackle here, I'm going to go with, you know what I might do here? I might go and tackle carbon dioxide, okay? So it's asking me for the chemical formula of carbon dioxide. So I know from memory that carbon dioxide involves carbon and oxygen, and in particular in this order it involves CO. Now here's where a little bit of technology formatting. We've been talking about how you can go and raise the cursor up for a superscript like an exponent. I also want to make sure everyone's comfortable with doing a subscript, and in this case here I know it's CO2, so I'm going to hit the control comma, and it's going to bring the cursor down. I'm going to be able to go and do this. And so now I know that it is CO2. Let me zoom in a little bit for you guys here. So CO2, all right? Now I need to bring that cursor back up, so I'm going to hit control comma again. Please note the cursor is back to normal. I can now go on to the next box. Now, what elements or atoms and a number of atoms are there in CO2? Well, I know that I've got one carbon, and so I'm going to say carbon equals 1 and oxygen equals 2, because there's two oxygens being shown right here. All right, next up, I'm going to continue on here. Now, is this a molecule? Yes, it is. The question then becomes, is this a compound? Well, I know by definition that a compound is a molecule made up of two different elements. And in this case here, carbon and oxygen, you got it. That would be a yes. Unlike things like ozone, which is O3, where it's just oxygen, ozone is not a compound. And that's me giving you a little bit of hint and help for the next one coming up. All right, now once you get your whole chart done there, you're going to scroll on down to the bottom part here. And it's asking you, and I do apologize, it's asking you to go and identify not only what type of bond brings these elements together, now this is carbon dioxide again, but also to go and adjust where the electrons are. Now, carbon dioxide, I know that carbon is, let's see, carbon is 1, 2, so carbon is 6 and oxygen is 8. Yeah, okay. So carbon is the 6th element on the periodic table and oxygen is 8. And so we need to remember our rules about the electron orbits. And so I hope you remember that the first orbit, you can fit up to 2, and that fills the inner orbit. And then the second energy level, the second orbit, can fit up to 8. So let's go and start off by filling this in here. So if you double click on carbon dioxide, and you're probably going to need to zoom in a little bit so you can see it better. And let's go 200. All right. So I know that I can go and adjust this information here. Now, I told you before, carbon happens to be 6. Oh, sorry, oxygen happens to be 8. So I'm going to put an 8 right here. And I also know that the atomic mass of oxygen is 16. So I'm going to put another 8 right here. And now I need to start going and putting my electrons around these orbits here. And so I'm going to go and make a copy of this because I do want to have more of these electrons. So I'm going to put an electron right here. I'm going to put this other electron down here. Now I still need to go and put in 6 more. So a total of 1, 2, 3, 4, 5, 6, 7, 8 total. And so that means there's going to be 6 in this outer orbit. Now, here's something kind of interesting. Because carbon and the 2 oxygens are going to share their electrons, we're actually going to go and set them up so that they're kind of spread out in a nice, unique, even way. So let me go and get a couple more here. So I'm going to go, so you notice I just did Control C to copy the electron, and then I did Control V to paste the electron, for those of you who are wondering how I'm doing that. Again, that's Control C and Control V and making a couple of copies. Now, I'm going to put these down here. Now, I'm going to actually need this one over here, and I do need one more. Copy and paste. Sweet. And so I'm going to leave them like that. Now, that takes care of this first oxygen. And remember, now all I had to do is double click on it and it's good to go. So I'm going to hit save and close. And you'll notice here that it's all the electrons are where they need to be. I've got 2 in the inner orbit, and I have 1, 2, 3, 4, 5, 6 in the outer orbit for a total of 8 electrons, 8 negatively charged electrons to offset the 8 positive protons. So now I need to take care of carbon here in the middle. So I'm going to double click on carbon. And for those of you who are already thinking ahead, you're going to do the exact same thing to the other oxygen as you did to the first oxygen. So again, as mentioned before, this happens to be a 6. So I'm going to delete that. And it also is another 6. And now I need to go and get my electrons all squared up. So copy and paste, paste, paste. I'm going to use a bunch of them. So I'm going to put 1 electron right here. Now I'm using X's in this model to represent my electrons because for a moment there, you'll notice I did use, I used zeros or circles on the other one. And so I need to go and set this up. Oop, I need one more. Nice. Now you're going to notice here, we have basically gone and put 2 in the center orbit, so that is filled. And now we've moved on to the outer orbit. And please note we got 1, 2, 3, 4 for a total of 6 here in this atom. However, watch what happens when I save. You're going to notice that both the oxygen over here and the carbon right here are sharing their electrons. Their electrons are right on each other's lines. They're kind of overlapping, if you will. In fact, if it really is going to be a stickler for some of you, I can go and move this up just ever so slightly. And I'll hit save and close again and bring that in. See how that looks. Nice. I could even slide it over a little bit, but more importantly, please note, so now this oxygen over here on the far left, this oxygen has 2 in its inner orbit, filled, awesome, and it now has 8 in its outer orbit because it's sharing the 2 electrons here. This, by the way, is a covalent bond where the elements actually get close enough that they can share their electrons. And so now that outer orbit to oxygen is also filled, making that atom happy. Now we're really, really close to filling the outer orbits of the carbon here in the middle, but we've got to do the same thing over here on the oxygen. So please remember, zoom in so that you can go and make the modifications, 200%. And again, we're going to delete that line and make it an 8. I'm going to delete this line and make it an 8. And now I'm going to go and start populating my electrons here. So I need a couple of them. And I know there's 1 electron at the top here, 1 down at the bottom. And then I'm going to go and put 2 over here. It's almost like 1:30, if you will. The 1:30 on a clock. Now, I still need 2 more over here. So I'm going to do Control C, Control V, and there's 2 more. Sweet. Now I'm trying to remember. I think I wanted them up higher. And one down here. And I think I should be able to hit save and close. And they should be close enough. Should be close enough. Oh, nice. Came up perfect. Look at that. So you'll notice there that we've got 1, 2, 3, 4 electrons here that are being shared between the 2 of them. And so now all three of these atoms now have a filled inner orbit of electrons for 2, and then a filled outer orbit of 8. And so now carbon in the middle is content and happy, and the 2 oxygens outside are also happy. And so this compound, because it's 2 different atoms, is complete and happy. And please remember, what type of bond is this? This is the bond where we share. So there's going to be a covalent bond. Okay. All right. Lastly, last one down here. This is sodium chloride. Now this one's a little bit harder, but I'm going to go and see if you guys can't try and figure this out on your own. What I do recommend, if you want to do some Googling, Google sodium chloride and sodium chloride ionic bond structure or model, ionic model. So if you Google if you Google sodium chloride ionic bond model, you should find some pictures. They're going to show you how to go and set up the electrons, at which point just go ahead and do this to both of these. Again, we've got sodium on the left, chlorine on the right. You will note that they're going to need to do some sharing here. And one caveat, I've told you before that the inner orbits, the orbits become full and happy. First orbit is 2. The next orbit is 8. However, the third orbit can be either 18 or 8. I know that's not really easy to memorize and commit to memory here, but the outer orbit can consider itself to be content and happy, the third level, at either 8 or 18. And I'm going to give you the hint. It's 8 this time. So go ahead and see if you can't go and try and figure that out and demonstrate it. Go ahead and move your electrons around, and go ahead, you guys, give me a holler if you have any questions. Take care. Bye.